Hi everyone, good morning. This is class 4 in the protein class series that I'm teaching you. Again, my name is Dr. Andrea Joss and I'm here for one more class after this. Today's class, with respect to protein, we're going to be talking about whether all protein foods are created equally. So essentially this class will be discussing protein quality. And we will be looking in particular at plant-based proteins versus animal-based proteins. And in this class, we're not going to discuss them in the context of exercise or sport per se, but I hope to do that in class 5. All right? So let's get started discussing protein quality. First of all, what is protein quality? Well, it is this measure of how efficiently a protein can be used to make other body proteins. So a protein that's of high quality, once it's ingested, it's broken down into its constituent amino acids, and all the amino acids can be used in various ways by the body, and they go to where they need to, etc. A lower quality protein source is one whereby you ingest the protein, your body breaks it down. However, in order to make new proteins, your body needs to get other amino acids from other places, i.e. it can break down other protein tissues in the body, or it just doesn't end up making that particular protein because certain amino acids aren't available. And so this means that this protein is of lower quality because it can't necessarily be used to make other specific proteins in the body. So protein quality is essentially dependent on two criteria, as you can see here. The first one is amino acid digestibility, and the second one is the amino acid composition of the particular protein. So we'll talk about each of these. The first one being amino acid digestibility. Protein quality does relate to how digestible the protein actually is, and so how your body can actually break it down and get access to those amino acids so that they can be used. Animal proteins are more easily digested and absorbed than our plant proteins. And this is primarily because of the food matrix in which they exist. So plant proteins contain other types of nutrients, as I've written here, anti-nutrients. These are things like phytates and oxalates and fiber and other such compounds within these plant foods that inhibit the absorption of nutrients. So they also inhibit the absorption of a lot of micronutrients, so they can trap calcium or iron or other such nutrients within its own food matrix that our enzymes have trouble breaking down. But this can also be the case for protein. And so this is part of the reason why plant protein sources are not as easily digested and absorbed by our bodies. So in fact, we end up excreting more of the protein from plant sources than we do animal sources. Now, if you have an isolated protein source from plants, like soy protein or pea protein isolate, any of these powders that you may put in a protein shake or, make a Beyond Burger patty out of, let's just say, those types of proteins are more digestible. They are of potentially higher quality because of the fact that they are more digestible. But still, because a lot of them are these plant-based protein sources, they do still lack certain amino acids. And so this is the next thing that I would talk about is the amino acid composition of the protein. Actually, the other thing I just wanted to mention regarding digestibility is at the time that you're eating a particular protein source, the digestibility of that protein depends on the other foods that you eat with it. So foods that contain fiber, if you're eating fiber-containing foods along with a protein source, then that may have an effect on the digestibility of the protein itself, as it all kind of ends up together in the stomach and in the intestine, as we've talked about. But these effects can be subtle. All right, with respect to amino acid composition, this is the other criteria for assessing protein quality. And not all proteins are created equal, like I said before. They don't all contain a full complement of essential amino acids, which are the most important with respect to protein quality. Remember, our body can make non-essentials. So we can see here the liver produces non-essential amino acids. So we don't have to worry as much about some of those being limiting in our protein sources. But certainly the essential amino acids are those that are most limiting. And so what do I mean by that? So what's a limiting amino acid? These are the amino acids in a protein source that are supplied in less than the amount needed to support protein synthesis. So there are particular amino acids, essential amino acids in particular, that are limiting within plant protein sources. And because of that, we need to either consume more of the plant protein in order to reach this critical amount of an essential amino acid, or we need to pair a particular plant protein with another plant protein that's limiting in a different amino acid, and that's called protein complementation, and we'll talk about that in a later slide. So there are ways to get around it. You can certainly eat well and eat enough protein and get the right amino acids with a plant-based diet. But certainly it is true that animal proteins are of higher quality for this particular reason as well. So there are, as I said, issues with incomplete or low quality proteins because they don't provide all the amino acids that your body needs. And as I was saying before, one of the ways in which our bodies can combat this is by actually degrading body proteins to release essential amino acids, these free amino acids, into the amino acid pool, and then they can be used by the body to make the protein that it needs to. Perhaps the body needs to make insulin or something like that. If you're only, it's a lot more complicated than this, but the point is that, we do need a full complement of our essentials to make the body protein. So we have to be aware of that with respect to the foods that we're eating. So there is a measure that we can look at by which they've classified the different protein sources based on protein quality. So there's actually two different measures. And I've said here again, protein quality is the ability for the body to use the protein source to synthesize new protein. So it's this anabolic potential of the protein source means that if it's a high anabolic potential, then it has a higher quality. And we measure protein quality by the PDCAS or the DIAS. So it says actually down here at the base of this figure what each of those mean. So PDCAS is the protein digestibility corrected amino acid score. And the DIAS is the digestible indispensable amino acid score. And the DIAS is newer, and it actually provides a score based on the limiting amino acid within the protein food. So it does tell us a lot, which is good. So let's look at this particular figure over here. This figure was from an article that Stu Phillips wrote, published in 2017. And as we can see here, we have some of these isolated proteins being higher on both the PDCAS and the DIAS scale. And this is indicative of a higher quality protein. So what do we have here? We have, let's see, milk protein concentrate, whey protein isolate, soy protein isolate, pea protein concentrate, etc. So these concentrated amino acids, like I said, are these concentrated protein sources. Even if they're plant-based, they don't necessarily have the as much digestibility issues because they're not within the matrix, the food matrix of the whole food plant or the whole food protein source. So they do tend to have higher protein quality scores, but they do still have limiting amino acids, as you can see here, which we have to be aware of. Then as you go further down the list, a PDCAS or a DIAS score of around 1. Well, PDCAS actually doesn't go above 1. The highest you can score is 1 on this scale. DIAS does go above 1. But in any case, a score of around 1 is a really high quality score. So whole milk, chicken breast, eggs, etc., you can see that these whole food protein sources are considered of high quality. And then as soon as you get into some of the vegetable protein sources, we have cooked peas, cooked rice, almonds, chickpeas, tofu, etc. You go down the list dramatically, actually. And so this is just another, this is the indication of protein quality based on these two classification systems, okay? And as I said, both of them assess protein quality by looking at the digestibility of the amino acids as well, or the digestibility of the protein source, as well as the composition of the amino acids within the protein source. Now let's look at this figure on the right over here. This was from a new paper by Gorson et al. In 2018. And they looked at various different types of proteins. You can see here across the x-axis. We have in the white bars the plant-based protein sources. In the gray bars we have the animal-based protein source. And then just for reference purposes, certainly no one's going to eat human muscle per se, but just for reference purposes, they've graphed the amino acid concentration of human muscle. This bottom figure over here is EAAs, so essential amino acids. So this is the percent of total protein as essential amino acids. This is methionine and this is lysine. And both methionine and lysine are essential amino acids. So it's important, again, that we get a full complement of these essentials in our foods that we eat, be it vegetable protein or plant protein or animal-based. And so what we see in this figure over here is that there are some plant-based protein sources that are of lower quality, i.e. they have lower percentage of essential amino acids than the animal protein sources. And I should mention that all of these are normalized to a single dose of protein. So a certain, I forget what it is in this paper, but let's just say for argument's sake, 25 grams of a particular protein source, okay? And I think it was somewhere around there. In any case, they're equated by weight, so 25 grams. And you can see here, so for the same amount of protein, there's much less of essential amino acid content in some of these plant protein sources than there are in the animal protein sources. Now, if we look specifically at some essential amino acids, I've chosen to show you lysine and methionine. And you can see in this figure here, these tend to be two amino acids that are fairly limiting in a lot of these different types of protein sources. And you can see that again from this graph over here. So these dotted lines here represent the critical threshold of amino acids that are needed to produce other types of proteins. So they directly relate to the anabolic potential of the protein source. And so we can see for methionine specifically, we have plant proteins being deficient in methionine. So most of them are quite deficient in methionine, whereas this is not the case for the animal protein sources. And then lysine is another one. We can see again that there's several plant protein sources that are deficient in lysine compared to the animal sources that are not. They're all above this particular threshold. Okay, so it's something to note when you're planning the types of foods that you eat and you're wanting to consume higher quality proteins. I'm by no means saying that you should always choose animal-based proteins, but the truth is that plant-based proteins are of lower quality, and in the next couple slides we'll get to discussing how we can combat that issue of lower quality protein such that those that are vegan or vegetarian are able to get adequate protein and adequate amino acids. So a couple take-home points regarding protein quality. We have complete proteins, which contain all of the essential amino acids. And we have incomplete proteins, which are missing one or more of the amino acids. And these these incomplete proteins also tend to be harder to digest. So these are most of the plant-based protein sources, legumes and grains and other such plant-based sources, which we'll talk about it in the next couple slides. Plant-based protein sources are generally of lower quality because they have lower PDCAAS scores, lower DIAS scores, they have limiting amino acids, they have anti-nutrients, and all of these work together to make the digestion and absorption of proteins from these foods potentially more difficult. Okay? And I've listed some of these over here. So they contain less available amino acids, greater impact of these limiting amino acids, and the presence of anti-nutrients. So let's look at some examples. Okay, so legumes are a plant protein source. They are peas, beans, garbanzo beans or chickpeas, black-eyed peas, peanuts, even soybeans are considered legumes. And yes, peanuts are legumes, they're not nuts. But anyway, these legumes are vegetable protein sources or plant protein, and they are considered to be incomplete. And this is because they are limited in these 3 amino acids, tryptophan, cysteine, and methionine. Tryptophan and methionine are essential amino acids, cysteine is not, but these 2 essential amino acids make the PDCAAS and DIAS scores of a lot of these protein sources lower. Okay, now I put a star beside soy because soy is actually considered to be a complete protein. It does have for the most part, it has a full complement of essential amino acids. It is probably the protein source of the plant proteins that is considered to be the most the most complete, rather. So I just wanted to put that out there. There are a lot of there's a lot of sources and a lot of research showing that it is more of a complete protein compared to some of these other legumes. But it is still a plant protein source, and when eaten as a whole food, it does have the element of anti-nutrients, which decreases its digestibility. Another type of incomplete plant protein source are these nuts and seeds. They do contain a fair amount of protein. Here's pumpkin seeds, and then here's a bunch of mixed nuts. So we have walnuts and hazelnuts, etc. And they are actually limiting in different amino acids than what the legumes are limiting in. So they are limited in isoleucine and lysine. And again, both of these are also essential amino acids. Grains and cereals, so this is where we can get some additional vegetable protein sources or plant proteins from grains and cereals. And grains and cereals are also incomplete in several ways. They are also limited in isoleucine and lysine, so similar to what we saw with the nuts and seeds. And this includes rice and wheat and other types of grain products. So one of the things that I mentioned previously as a way in which people can overcome this issue of protein quality, particularly in vegetarians and vegans, and they use this fairly often, is this notion of protein complementation. So this is actually the combining of plant foods to improve protein quality of the diet, as I've mentioned here. So we know that there are certain plant protein sources that are deficient in either methionine and cysteine, methionine, lysine, cysteine, tryptophan, etc. But there's different ones that are deficient in different essential amino acids. So the idea is if you create a meal that combines these different plant protein sources, then essentially in your stomach, you're going to be breaking down and metabolizing, digesting and absorbing in the intestine a full complement of amino acids. So let's take a look at this for a little bit. So as I told you before, so rice is a grain and it's deficient in isoleucine and lysine. So lysine is listed here. Rice is deficient in lysine, but it does have a complement of methionine and cysteine. Whereas beans, on the other hand, are legumes, and they're deficient in methionine and cysteine, but they're sufficient in lysine. So if you combine rice and beans together, you end up with a full complement of your essential amino acids over here. Or of your amino acids in general. Not all of these are essential, but you get the idea. And this is no coincidence that in various parts around the world, certain countries in Asia, let's say, just as an example, and even Mexico, there's other countries where corn and beans and hummus and pita bread in some Middle Eastern countries, and rice and beans in some Caribbean countries, or in Asia, let's say, they use rice and tofu, like soy. There's a reason why those foods go together. And if you look back centuries and centuries, some of the staple dishes of our ancestors were like this. If they didn't have access to meat, they would complement their proteins together. And they probably, I don't know this for certain, but it's highly unlikely that they knew about the science of amino acids and protein complementation at the time when they were eating rice and beans. But they probably realized that their population thrived on consuming foods in this way. And this was also what was available to them. So I think it's so interesting how these dishes have come together. But really, if you think of it from a protein quality, a health standpoint, things like that, I think it makes total sense. So I think this notion of protein quality and then looking at some staple foods in various countries, it really makes sense, as I said. So this is the last slide for this lecture. This is a short lecture. I'm at 22 minutes right now, I can see. And the reason, I just wanted to say, the reason why this lecture is short is because the next lecture is long. The next lecture is the Protein 5 lecture, which I may decide to split up into two. I haven't decided that yet, in which you'd have to watch 2 lectures on the last class. But that class, I'm talking about sport nutrition and protein for sport performance and other such things. So that's a really super fun class that I love giving, but it tends to be a little bit longer because I keep incorporating new things. So this is why I wanted to keep number 4 short so that we can dive into things a little bit more in class number 5 with respect to protein. So anyway, I just wanted to show this infographic to you. Again, just to come full circle, to talk about how not all protein is created equal. And this was what I started with at the beginning. And again, this relates to protein quality. So we have some animal-based protein sources that are of higher quality, beef, chicken, and whey protein isolate. And then we have some plant protein sources that are of lower quality. They just are. They have different amino acid compositions, and the digestibility of them is lower. So just as example, black beans and tofu. And as I've mentioned all along, I've shown you how we can overcome the lower quality of plant proteins such that we can thrive on a vegan or vegetarian diet. Because protein is still important for everyone, regardless of where it comes from. And then I also just wanted to throw this part in here as another infographic. And actually, they're both from this interesting study published in Nutrients if you want to take a look. But just to put it out there, and we kind of saw this a little bit with the Beyond Burger, the plant-based burgers and things like that, how, not all plant protein sources are healthy, but also not all animal source protein is healthy. So the point here is that lower protein quality does not necessarily equal lower quality nutrition. So just to contextualize this a little bit and put this into perspective, the vegetarians that are eating black beans, whey protein, and peanut butter, even if you replaced whey protein with soy protein, let's just say, and called this a vegan diet, These are healthier choices than any of these omnivorous choices. So hamburgers, milkshakes, and fried chicken. So, you know, the devil's in the detail sometimes. And if you're looking at the diet as a whole, as opposed to just, you know, zeroing in on a protein source, I think for the most part, we have to also focus on the overall health of our diet. And we should be consuming a mixture of plant-based and animal-based proteins if we choose to. Otherwise, certainly, you know, as I've been saying all along, you can get a lot of your protein that you need from vegetarian sources. So I just wanted to kind of throw that in there just to bring it back in context. All right. That is it. Thank you very much, and I will see you soon.